Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And, this week we got everybody back together again. And, we always talk about, 3D printing slicers and getting into cybersecurity and coding, and, like server maintenance and stuff like that. But, like, we know, and I know we've touched on computer-based hardware before, just as a quick touch off, I think it was, just as like a side conversation. However, we want to kind of get into what software what type of hardware and software do you need to have to get the job done? Mm-hmm. Is pretty much the topic for today. Is getting the job done. What hardware and software do you need? So we can break it down into different categories from the IT/OT side of the house, cybersecurity side of the house, server development and stuff like that. And, also into the 3D printing and stuff like that you need to run, like, some of the machines out there now. Like your Cricut, your 3D printer, your vinyl machine that you're going to be running inside your house. Your vinyl cutters, that type of stuff. CNC, little mini CNC machines. Yeah. Nothing too insane. Are we saying that you need to go out and spend money on a gaming rig? Only on certain occasions. Or on a full server? Yeah, probably not.
Getting a server rack 128 gigs for one printer?
Hey don't judge.
Nah, I'm not pointing any fingers.
Don't give me any options, all right? I can still run Octoprint. I'll just run on a big virtual machine stack.
You just have extra processing power. It's fine.
Just say I'll never have to slice on the PC again.
Yeah, right. Instant slicing.
Instant slice.
So
come to a server right near you. Instant slice.
And your printer's in the rack as well. That'd actually be pretty cool.
It's the Porto printer.
Yeah,
Instant slice on board.
Cool. Put some wheels on the back. That'd be cool. Porto printer. But no, you've already touched on a few things. I mean, there's so many different angles that you could
Yeah, there's different things we can hit, but
attack. But like, I would like to start off with the basics. To be honest, like jumping off points is like, I just bought a printer. Is my printer safe? Is someone going to hack into my printer and connect to it? I mean, to be honest with you, there's no Wi-Fi, so you're fine.
Depending on what printer you get, though.
If the person's inside the house, that might be a problem. Or inside the facility, whatever. Then they might be able to get onto it or print something that you don't want printed or something like that. Yeah. But at the end of the day, there's always things that you can kind of add on from the basic to increase security as well as increase... I guess intellectual property too, theft. I guess is a thing one. Too. So if I'm making something with a CAD software, how comfortable are you or am I with the safety of that, that file? Like if I post it on Thingiverse, does that mean everybody's gonna grab it and print it, and then now I get no credit for my own intellectual property, right? Or is it something where it's very secure? I mean, honestly, in the most cases, you're not connected to that network outside. Yeah. When you first start out, you have what, motherboard? You have that's pretty much the most. Yeah, the LCD board. That's the most advanced piece of tech that you're gonna have.
Unless you go out and get like one of the printers that, like the snap makers and stuff like that have Wi-Fi on board.
The bamboo, yeah,
bamboos. Even then, you're so air gapped at that point in time, because now you still have to have a VPN to get into your network. Mm-hmm. Now you're worried about an insider action if something was to happen. But like you said, there's many ways to secure these things. Yeah. And the best thing to do is remember that you must secure your own PC before you can secure the printer itself.
That's a good start. Secure your own network.
So I think the big thing is like we're talking different levels of hardware. So a bare bones system would be, say, a Enderpro 3 right out of the box.
Yeah.
So right out of the box, basically what you're gonna get is you're gonna get a motherboard, they call it, but basically it's like a controller.
MCU,
yeah. And that controller basically gonna have your drive circuitry for your steppers. You're gonna have some circuitry for controlling the heat. It'll probably be some PID algorithms running in the background. You have interface possibilities with the LCD display, and then the other thing will be the actual components. So you're going to have stepper motors. You're going to have switches that'll actually be the physical point that you use to say, "Hey, I'm at this position." Then you'll have some mechanical components such as your belts and your pulleys and so
like that,
forth. But so back to we saying a bare bones system. So with a bare bones system, basically, it's like getting a desktop PC, and that desktop PC basically has a home version of Microsoft. So you would get a home version of Office. So that's basically what you're getting. So you're getting a base system that comes with a few I would say it has a few programs that are like
it comes with
Auto
firmware
Home. The firmware's already installed. You may choose to upgrade that, and that gives you some benefits to that. Especially if you want to get off the ground and just start printing, say, really advanced stuff, then you may say, well, hey, I want to upgrade my firmware. Hey, I want to upgrade the springs to make the bed more robust. Hey, I want to, you know what? I don't want to go and put this on an SD card and transfer back and forth. So I want to get, an orange pie, or I want to get something that I can use to do that interfacing with me. Or, maybe you're a really, high-tech guy and you use a server with a lot of resources, and, you say, hey, I don't want to use none of that. I'm going to use this. So that's some of the things when we're talking about hardware. That's what we mean.
Now, I like the way you're heading with this. Okay, and I think this might be kind of an avenue that we kind of stretch things out a little bit. Is okay. You talked about the beginner stack, which is the Ender, right? So let's kind of keep divvying that up. Okay, so we have the beginner stack, the intermediate stack, and the advanced stack. Okay, most of us kind of know what the advanced stack is. However, what else goes inside that beginner stack? What type of PC do we need? What type of switching and stuff like that do we need if we need it?
Yeah.
What type of auxiliary hardware do we need to run a basic stack? Like your basic stack at that point isn't going to take in Octoprint or take in Clipper or take in any of that. You're going to go towards your medium to advanced or your intermediate course area. And then so now if you're building your beginner stack, what type of PC are you going towards?
Well, like I said, most of the time, I would assume today's consumers have a laptop.
Yep.
And basically the laptop would have your slicing software, and you would basically take whatever model you get from Thingiverse or you create yourself, and then that prepares that so that it's hey, it conforms to whether you're using a Prusa slicer or super slicer, whatever you're using. It conforms to, hey, this is correct. I don't see any errors in it. I don't see any gaps. I don't see any collisions that may or may not happen. And then, hey, here's the G code to go with it.
Yep.
You take that, put it on an SD card from your laptop. From your laptop, you go to the 3D printer. There's a port that you can put the SD card in. You navigate to it, and then you hit manual, and you select that particular thing that you want to print, and you have a go at it. However,
those USB dongle things, you can break them things quickly though. But I can tell you that right
there's
now.
a however. The however is you do want to pay attention, no matter what the slicer says, to the first layer.
Yeah.
The biggest thing that I'm learning is the first layer is the most important part of the 3D print. If you happen to have an issue with that first layer, you may not get adhesion, and it may knock off the bed itself, or you may get shifting that you don't see until you get to the later ends of that print, and you're like, oh man, this sucked. I spent 18 hours and
Okay. Yeah, that makes sense.
No, yeah, I was just gonna add because like so you broke it down very well because like you're thinking about the device that I would need to get it going and it is a very manual process like your SD card, very physical. You have to be at the location. Like there's a lot of limiting factors that are gonna force you to be at the printer, and for a lot of reasons, a lot of people prefer that.
Yeah.
That more intimate, that lower level. There's no chance it's connected to the internet. I don't have to.
It's air gapped.
Yeah, so your only thing that's connecting to the internet is your laptop, and what you're downloading is only things from the secure website, Thingiverse, printables, whatever your choice is. And at the end of the day, you're not. I guess the thing is as an advanced or as a beginning user, you're not going to be. Most likely, you're not going to be advanced in CAD modeling.
No,
so
right.
you're pulling other files. You're pulling other people's things.
You're using like Thingiverse
You're
and stuff
printing
like
as
that,
much-
Tinkercad.
Yeah,
and whatnot.
exactly.
Now I would like to add one thing. I left out one step from the Thingiverse.
Mm-hmm.
I don't care where you get it from, whatever verse.
Mm-hmm.
You scan it before you put it on your PC. Before you open that file, before you launch that file,
Oh, yep.
you scan it. You scan that file and make sure you don't have any issues.
You use Linux, you wonder why the problem.
That's true too, unless the guy's savvy enough to put some.
So, but
Linux
now
worm.
the thing is that that brings me to the kind of the point, the little kind of the one of the pieces of this is slicers. Like I started with Kira, okay. That was the first friggin', I guess you'd say, gateway drug into 3D printing. I think I've tried them all at this point. I even tried the one that the Creality sends you, the Creality slicer. I'm going to tell you right now that does not work.
Yeah,
Go try someone else. All right, that is a big nope. That is about as big as a nope rope as a snake is for some people.
I didn't even open that file. I was like, I know I don't want this.
I did, and the problem is it's built in like Java Beans, which is like it's like Java Swing, so it's like the old square characters, and you're like, am I clicking on something, or am I gonna like worry about having to click Clippy down the side of the corner for something to pop up because it feels like I'm back to Windows 95 again, or XP, back to the actual good days of Windows.
Well, I'm
instead of the
curious.
crap that we got now.
I'm just curious, like, how old is that Crucible? What version? Like
The Creality one?
Yeah,
It's
how
probably
old
it's probably like
is that one of the first ones?
Yeah,
or-
it's like Slicer
probably
3D, like version like 1.0 is still running on like Java Swing.
And it's interesting that they hadn't made any improvements
They don't care.
from that
So
time
they're
to now.
Well, it's batch. It's batch at that point. And the thing is most of the time they know people are going to change the slicer anyways.
Yeah, it's just curious because what you're talking about is like the original word hacker meant that somebody was taking things apart to make it better.
Yeah, tinker is a more
it's
crude word.
It's not like I could give you an example like a guy named Captain Crunch. They figured out how to take tones, and with tones they were able to compromise the phone systems and make long distance calls. But they figured that out because they figured out the tones. It wasn't a malicious thing. They just figured it out, and that's the thing. What I'm saying about like these the progressions where we got to where it started out. Hey, here's an appliance that you can use to print these things. To people like, whoa, you know what? This is like a CRX. I can soup this thing up. And it's and the people in the hobby have driven the
Civic
industry.
of the printer world.
No, yeah, it's true because like at bare bones entry level, you don't need much.
Yeah.
You don't need much.
And
But
the thing about
deeper,
like
it's-
some of these slicers,
expands,
especially we're talking about the beginner slicer. I'm not saying that Prusa slicer is not a beginner slicer. You can bite me on that one. Same thing as super slicer, not a beginner slicer. Okay, it's not that you're gonna have somebody who's never ticked up a printer before go, ooh, I'm gonna use this. Unless you're using a Prusa or you're using something that requires that printer. And you didn't use the smart idea and go buy an El Cheapo Ender 3 just in case you blow it up. So, and the thing is Cura is free on 99.9% of things out there. It's free. And you can even do advanced things with Cura. I don't know. What was your first
Slicer.
slicer?
Prusa slicer. I'm gonna be honest with you. I tried Cura, and I know that you'd like Cura because of Python. It uses Python scripting in a lot of things, and it is for the most part it is pretty clean, and it is useful because it can do resin SLS printing as well as FDM printing. So like I know I'm saying a lot of positive things, but at the end of the day, I felt more comfortable with how the information was displayed to me in Prusa Slicer, and moreover in spilling over into Super Slicer now.
Yeah.
It made so much sense to configure the application with those pages that Cura, it just was like, this is too much to learn. This here, it blends easily. I can intuitively go from this to this and get my job that I'm looking for.
Like I changed over when I entered back into the hobby.
Yeah.
I went, jumped in full force at this point.
Yeah.
2 feet in. I started with Prusa Slicer because I said, well, I've already tried Cura once. It was okay, but there's a lot to it, a lot of lost words that just don't mean anything.
There's a lot of little things.
And the thing is I think it's because the menus aren't set up correctly. So, but that's my own, software testing background, OCD that kicks in, and it's not user friendly, and I kind of forget about that stuff.
It's the quality of life things. It's
right.
Like if it doesn't,
when you come from system testing and software testing, so you kind of look at the usability features, and when something doesn't work, you get this like OCD like twitch. You're like, not gonna happen. Any of y'all who works out there in software testing knows what I mean. So, what'd you start with, Ed?
So I started with the Prusa Slicer. That's what I'm still using. But I was going to ask you two guys. So when we were talking firmware, so firmware is actually embedded in the hardware, and it's something that you can change. So I was curious from you guys, why did say Marlin not offer the same capabilities that Clipper? What makes Clipper so much better far as end user usability, far as power? What? So
that moves us into our more intermediate category. We've officially left beginner category. That was somebody kicked the back of the SLS rocket and darn thing head towards the moon. So with a vengeance. So intermediate category. We start dealing with your bigger enders, like your Ender 5s, your Ender 6s, whatnot. You start dealing with more complex printers. You start dealing with like some of your Bamboo Labs at that point. You start dealing with some of your Prushas at that point. You're not really getting too big into the build-it-yourself kits yet. However, with those comes the fact that now you're in the hobby for a little bit. You have a 3D, you have a Raspberry Pi lying around, and I'm going to load Clipper to it. So, because I want a new firmware. However, the one thing about the Marlin side of the house is you can edit the Marlin firmware and reload it to do whatever you want it to. However, you're still dependent upon like Octoprint to kind of see what's going on. While your Clipper is a software package. So you can create your bin files. It's all written in Python, 100% open source. If I have any questions about it, they can see the code base. I actually have the code base load up on my printer on my PC in there because I was looking at it, seeing how it was written. Just curiosity, out of all things. So it's a package that's broken down to when you run your make menu config. You put in all of your MCU details and take that MCU detail and run it as a bin file. So, and then you take that firmware bin file and load it to your printer, boot your printer real quick. It'll load that bin file in while all the heavy lifting has now moved from your MCU hardware to your Raspberry Pi hardware. We have a little bit more core to deal with.
And what's the greatest benefit of that?
I think that's
the biggest benefit because it's the smoothing of data coming from one spot to another spot. So you're doing all of your slicing and your commands off in your reading of the G code on one thing, and all their motherboard at that point is doing is just taking commands at that point. Yeah. It's G0 this, G0 that, so it doesn't have to think while it's printing. So actually, your stepper motors are smoother.
I think that's the
at that point.
So it's more efficient.
It's more efficient. Yeah.
It's so basically what you're doing is you're relieving the computing power of the motherboard or the MCU to focus on just the hardware.
Right.
Whereas the I guess the slicing portion of it
is done on
in
the
another,
Yeah.
CPU.
Yeah.
Yeah,
or
and the thing
another
is you can use anything. You can use Docker, you can use VMware, you can use anything that you like. Yeah, I'm using CAN bus, but that's a whole other bag of nibbles. So, but the thing is with that is that package also comes with systems called Mainsail, and comes with or Fluid, however you want to break it down. Moonraker is also on there, which is an API-based system that can actually you can pull data out of your printer a little bit faster.
Yeah.
You can pull your logging details out. You can see what your logs are. You can edit your G-code file. It's about they're right there on the front end, so it's more user-friendly.
So would you say it's more suited for batch printing? So say for example you wanna print. So for example, how would I approach batch printing from say a Prusa slicer with Marlin and say I don't know whatever super slicer or clipper when I want to do multiple parts at one time?
So I think I want to step before I get to that answer. I want to step back because I was kind of letting you guys. I mean, Nick did a great job explaining kind of the whole process around those things. The main reason is like to get a printer in everybody's house. It can't be $3,000.
Mm-hmm.
No one's gonna buy that. Nobody wants that. They go get a used car. You're not getting a printer for that.
No.
So in order to get into everyone's house, everything had to be slightly degraded, right?
Mm.
Or you kind of take out all the bells and whistles like a filament sensor. Like you don't get a direct drive extruder. You get a Bowden tube because plastic's cheaper than metal. Like so those are some of the things, and the motherboard was not left out in this matter. It definitely is underperforming, and in that case, if you're minimally using it, absolutely going to be perfect. Absolutely not going to have a problem. Stay on Marlin. No one's going to know. Marlin is actually technically RepRap 2.0. It was one of the original firmwares, but when you step into the Clipper side, you're absolutely right. The batch printing is much better. You have visibility on your prints, Moonraker and things like that.
Queues.
You can get a camera connected. You can get MQTT set up, Telegram bots. So there's so many more. It's not only the upgrade or I guess redistribution of processing power because the Pi is going to be able to handle that much more than that. Than the motherboard, because the motherboard is technically it should just try to focus on the steppers as opposed to trying to interpret code I'm sending to it.
Well, it's like a microwave. When you put in whatever to a microwave, there's some predefined things that's there. But basically, when you hit the button, the microwave just does whatever you ask it to do.
Right,
it's not thinking about
exactly.
So
it gets to a point where it's you are one of the limiting factors as well. So how you use Clipper also can limit your features and how useful they are. You can have macros getting ran that you're not even using. Like for me, I've got bed tilt calibrated, and every time I run a print, it says, I don't know what that is. But you know what? The print finishes. I don't got time to deal with that right now. We move on to the next step, right? It doesn't hurt anything. But all it's doing is adding features. It's adding customizations, and it's adding not only that. Sometimes it could be adding safety. That's when I added the filament sensor, and now this processor that may have faulted out on the first board, the 4.2.2, the stock one that comes with it. Now it's going to be able to be ran on the Raspberry Pi via Clipper, and without an issue.
You also get an e-stop button now.
Yeah, you get a lot of functionality.
You're getting quality control. You're getting some safety aspects, but it reminds me back of the old days when processors were limited to a certain speed, and then everybody figured. Well, not everybody. We discovered overclocking.
Yeah.
We can almost say that basically it's the same type of tinkering. I mean, maybe not on the same scale, but it's the same type of tinkering. You know, the consumers or the users got the hardware. They said, "Hey, this hardware can do a lot more than what what they said it can do."
So it's funny you bring it up because it immediately goes into the next level, I would say.
Yeah. Now I'm gonna say this. We start talking about Clipper and stuff like that. Like I was a very, I guess you could say, early proponent of Clipper. Thanks for people at work.
We fought it for a little.
And I went straight. I was sure what I'll try it. It's not gonna bother me. I came home one day. I was bored. Probably had a beer or two, and went, let's try this and see what happens. What's the worst that can happen? Well, the addiction begins, and then you start realizing I can tinker. I can now write macros and change their code and do what I wanted to do. Woohoo!
Little random things.
It's you get to the point where it's like, oh boy, and you kind of continue on, right? Well, now John, on the other hand, you're trying to talk him into doing Clipper. I'll get around to it. I'll get around to it. I'm stuck on. I like this stuff. Okay, we'll see how this lasts. Then it turns out.
Who said, I'm sticking with it.
The problem is, he fought it for like 6 months before he goes, okay, fine, I'll try it.
Yeah, I don't think I've gone back.
And it kind of stuck because the thing is you start getting that ease, that usability thing where you kind of the comfortability.
Oh my god! I thought Octoprint was nice.
Yeah,
it's better than Octoprint.
Well, now as we I guess we can slowly but surely progress into what we consider insanity, which is your more advanced level printers and printer types. You start getting into your Vorons, your Core XYs, your other types of the full Bamboo Lab versions. What is it? The Prusa XL now that's coming out soon.
Yeah,
that's going to be insane.
They also got their resin printer they just came out with, the SL, the S1S or something like that, or S1.
Yeah, but it's that stuff that that's where Clipper is mandatory. You can't even build a Marlin for that. You can't do anything with that. You got Clipper on the books, right? But the thing is if I go back to our intermediate side of the house, right? You start dealing on your PC side of the house. It's the same thing. You don't really need something too heavy at that point, unless I would recommend going up to a possible gaming rig, a gaming laptop, because of the fact that now you're probably going to be building your own G code at that time. You're going to start doing your own modeling. You're going to start running modeling software.
Especially with the modeling. You're going to have to have that with modeling. Yeah.
Like, I run, software on my PC for, my 3D, for the AutoCAD and stuff like that. Just stuff where I can kind of see, kind of what's going on. Especially when I was building the Voron. But the thing is, so you want to slowly but surely grow to a bigger PC. I'd say, you'd be happy right about 16 gigs of RAM and a dual core. I think, it'd be easy. You're not really talking anything too hefty on the price tag. Please don't try a Chromebook.
It's not gonna work.
We still haven't seen that even work yet. Actually, but they do have that.
It might. I mean,
well, I take that back.
We got some web-based Tinkercad.
You got Tinkercad. You got.
It's not gonna be perfect either.
What is it?
It's gonna be a little janky.
Cura is now web-based too on occasion. Yeah.
You can get Ultimaker doing it.
So so you got that type of stuff that you can actually do in a Chromebook. However, I want to recommend it. However, if that is your gateway, do it. Yeah. Just get into the hobby at that point. But as we get into your more, we kind of peruse through our intermediate stuff. Now we go to the like I said, the Vorons of the world.
Danger zone.
Yeah, exactly.
Well, think about this too while you're on that thought. So FDM and resin. Mm-hmm. Resin is not a intermediate, and is definitely not a beginner.
Yep.
No, not at all.
So I'm saying, even the material you use can be more advanced.
Now,
ABS. Yeah. And some of the more are fancy.
Here's what I think about the resin printer, and this is
what I'm saying.
And I think this is going to extend to the conversation. We're doing well on time right now, so we're doing actually pretty well. I think it's its own category. At this point, I don't think you really have a beginner, intermediate, and advanced. I really think we got beginner, intermediate, and advanced. Then we start getting into your alternative 3D printers, like your resin printers, your SLS printers, your like you said, new methods, of 3D printing.
Well, I guess what I mean when I say beginner,
additive manufacturing.
When I say beginner and intermediate, we're talking about somebody that's probably this is their first printer.
Doing PLA,
they haven't changed many things. Yeah. They probably only done things like bed leveling and simple bed leveling. They probably still have the knobs and the original springs on the 3D printer, and then they probably are using Thingiverse. So they're probably not even generating their own CAD. Yeah. And so when you start talking Resin is not. Yes, it can be intermediate, but you have to have some experience with it because it is not the same as FDM.
Yeah.
There's
FDM,
also-
you just print it and take it off.
So
It's not the same with resin.
Yeah,
so
but
that's what I mean by
yeah. We'll get to
Right,
that. I think
absolutely.
we'll get to that
we
category.
could do a whole episode on resin printing. I'm gonna
You
be
know,
honest.
well, once we get done with the advanced
Alternative
category,
printing.
we'll go into the resin side of the house and kind of tinker in there for a little bit because that's where we have a little bit more safety concerns and stuff like that than what we're dealing with
A lot of bit.
FDM. For example, it's like we did a blog post. The FDM is the future of manufacturing because technically it is. It's how it goes. You have FDM printers and that are running off of ABB robots. So I wouldn't count that as an advanced technique. I would count that as an alternative. Just because it's absolutely insane. So it's pellet fed 3D printers. So in your advanced printers, you're talking about your Vorons, your Core XYs, your Ds. That thing is your Deltas is going to be definitely an advanced printer. If you start with a Delta printer, well, more power to you at that point.
Man,
You got me on that one.
I'll be impressed.
I want one.
How do you
I think they're
level your
cool.
bed?
Yeah. How do you
Does
level a
it
circle?
move?
Does it heat up in rings? Is it like Saturn? It's
Lots of questions. We need one.
we need one to tinker with.
Yeah.
So, but the thing is, you can get the different filaments, and I think at the beginning you're talking about PET-G and PLA. You start getting into your intermediate. You start getting into say your PLA, your PET-G, your ABS, your TPUs. And I think getting into your advanced, you're talking about your nylons, your nylon X's, your PETs, your that type of stuff. Your outside the ordinary engineering based filaments. And with that, those are systems that require you to run the Clipper firmware stack. That's just how I see it.
It needs so. What I've seen too is that when you go bigger on these printers. So before I get into that actually, so let me explain a little bit more of why I would say that those printers are in your advanced level. The Voron, that's not a manufacturer that says like Creality is this is the Ender 3, like Prusa this is the i3, like all these other brands, they have a name. Anycubic, the Photon, like they have names for their printers. Voron, that's not a company that manufactures it. They sourced a bill of materials. They said you can buy these parts, you can put these together. Here's a manual, and most of these parts can be 3D printed. This is up to you. Do with this knowledge. It's built by the people for them. Use this knowledge how you will. And to be honest with you, Nick's got his actually moving and lighting up and grooving. Mine kind of caught fire, but I wouldn't say a full fire. Just started smoking a little bit, but
It's burning off the oils.
Let me just say, my website connected, so I am online. Printing, no.
You get there.
But at the end of the day, it's
baby steps.
That's why I would call that an advanced printer, just because we had to build it from every nut, every bolt, every extruded aluminum piece.
As opposed to just assembling a few parts.
Yeah,
I had to even grind out new holes or drill out holes to mount things that weren't necessarily part of the main plan. So that is why I would say that is advanced, almost like past that at that point. Mm-hmm. But the idea behind the system, Core XY, or in any matter, Core, Core Y, Core is
Core Z.
XZ. There's a whole bunch of things like that. But it's so you start to think about what does that mean and why does that make it more advanced. Your standard Cartesian has the Y that's moving forward towards and back. So it's you think about like an earthquake like example or tower that they kind of test it with, where you have like a pile of sticks or popsicle sticks and it's shaking until it falls. Your print is doing that same thing, and if you have it hollow, it's going to keep shaking, and at some point it's going to peel off because it doesn't weigh much. And if you have it heavy, it's probably going to peel off because it's heavy. it's stuck. The taller it goes, the worse it gets, because you don't even out your density as you're printing. You can do that, by the way, but that's on an advanced level. You're evening out your density. So that's
center of mass. It's going to as you go up,
and it's going back and forth.
Change.
So instead of doing it like that, eventually it might get to a tipping point, right? That's a little bit inefficient. The core XY, that bed doesn't move in any direction but Z, so it's moving up or down. So you're much more controlled with your center of gravity, your center of mass, when it's moving, and the hot end is the only thing doing all the work. So for me, in my mind, that's one reason why. Delta is another way you can explain. It's got some crazy pulley systems in some type of triangle fashion that can kind of get to all points of the bed's fixed on there.
It's fast,
and it moves. And that's also a piece that I was gonna say is that the Delta printers move. The Voron can print a benchy in 5 minutes. Not pretty, but you can say that benchy is a benchy. You can tell it's a benchy. So at the end of the day, it's even pushing the bounds of the speed of creation as well. So that to me is not easy to control, because I've had to cut mine down to 75% in order to finish a print. Like otherwise, it's going too quick for its own good.
Right. And I think you get a little bit more accuracy too when you like sometimes you don't need all those axes to move. You can do the same thing with less axes.
You're creating turbulence.
And I'm saving energy. I'm saving energy.
Yeah, as well.
And then I can also, maybe I want to add a conveyor. Yeah. Now I have another axis free that I can add a conveyor when I'm finished, that I can tilt that bed and, hey, shake that part off for me.
Or knock it off.
Yeah,
I've seen a few prints that have an arm that you could program some G code.
Yeah.
And that's even more
the NG code,
where you can add G code to where it's actually cleaning your bed off for you, or purging at a certain time. So you purge when you switch colors, if you're switching colors. So there's just so much more that you can do with it. It's when you get to that advanced level, it opens up so many more doors, because then you can start worrying about multiple materials, multiple colors, like.
Well, what about when you start going to dual heads?
Yeah, there you go. Like it's changing out.
I
was gonna say we should probably do a whole other episode on alternative printing.
Yeah, because it's crazy. We saw a 3D printer the other day that had 7 nozzles.
Yeah. It's like ridiculous, because like the first thing that comes to mind.
They use was it like a bellow?
Yeah, it opens and closes.
Opens and closes.
Oh, so
the variable nozzle.
So that was the one when we saw that. That's game breaking.
Now the one that's got the 4 different colors that come through the same extruder and spins as it's coming down.
Yeah, that's Harvard's study. That was crazy, because not only can that's like printing, but it also can put conductive materials in parts of those tubes, and it can create resistors. It can create like your electrical components. It could 3D print those things instead of it. Yeah, it's going to that would revolutionize, and that's why that's so huge for her to even be able to get it to spin on an axis like that and twist it. Incredible to me. But I'm going to be honest with you. We could probably have a whole other episode about
just alternatives.
Just like not even just alternative applications of 3D printing or the processes, because like.
And that's something that we'll definitely cover, because that's something that I think we need to cover. As we look back at the shows, the conventions that we've seen online and stuff like that, the ones that we eventually want to go to. It's just the stuff that they have there is absolutely insane. But that brings me to another point when you start getting into more advanced work and stuff like that, is the use of Octofarm. Because you can use Octofarm to control all your Clipper printers together, or all your Marlin printers together, as long as you're running Octoprint. And that'll allow you to control every one of those, send G code to every single one of those different printers, or send them to all the printers at the same time, as long as they're the same printer. Yeah. You don't be sending my Voron 350 by 350 by 350, print to an Ender 3. I'm gonna tell you right now, it ain't gonna work. You can try it. It'd be hilarious to watch it happen.
It's going to try to get to that point, and it's going to click until it thinks it's done.
Yeah, right. So, but the thing is, but that gives you more control. It also, the thing is like Octoprint, for example. Sorry, not Octoprint, but Octofarm also has the ability to do like printer spool management. You know, what type of printer spools do you have? What is your cost per printer spool? And all this stuff kind of built into one open source application for people to use. So that's more or less on your advanced side of the house, because then you can schedule those prints out and stuff like that. You know, and then you can start using it where you only want to hook up like a server and a switch and hook everything up to the same switch. So now technically you're air gapping because you're no longer having to worry about Wi-Fi. You're hooking it all up to a PC, and then you just kind of remote into the PC from a hard line.
Yeah.
Or something like that to kind of see, you know, kind of what's going on. So because in there, you know, 3D printing, I think air gapping is the next, is the thing that we have to worry about. But also the fact that you can take Keycloak, an SSO based system, and lock out your displays. Like for example, that's one thing I like about Clipper is I can take Clipper and I can hook it up to an SSO, and I can block out every single one of my Clipper instances with a use of a Keycloak instance where you have to have username and password to get into them. If not, you can't get into that printer.
So when you say SSO, we talking single sign-on?
Single sign-on or dual sign-on?
Yeah, just so.
So you know that, or if you want to do like, you know, where you have to use the Google Authenticator, you know, a dual point type of system. You know, to say, okay, cool, let me get my PIN so I can log in. You can set all that stuff up, and you can lock your printers out that way.
Yeah.
You know, guaranteeing that only people who, you know, if they work inside your building have access to those printers based on the fact that they have logins. You know?
And I'm assuming if you have facilities, you have some type of physical security where there's going to be either some PIN code you put in, or there's going to be a badge you use to get inside. So there will be a point that you have to go through.
There'll be multiple layers of security before you get to your printers.
Once you get to a facility, you know.
It's like also, you know, the big thing is going into our world of ITOT type stuff is using OISNA keys to be able to log into your printers. So you can use an OISNA key and it'll set up to that SSO and point you to the direction you want to go in.
Well, if you like Apple, you know, Apple sell RFID tags that you can
Apple
do
tag.
some of the same Apple tags. You can do some of the same things.
And the RFID tags you can buy on Amazon and build your own system for it.
Yeah, if that's your thing.
Yeah,
you know.
right. And it's like, you know,
If
if
you can send them to us, we'll do it.
it's like also the other thing is you know, this is kind of like, you know, thinking, you know, more advanced ways of secure your stuff. Like if you do have a Core XY system, use usually an enclosure. All right. If I want to lock that enclosure, I'm going to use an RFID tag. So as long as I hit the button, it'll open up and it'll unlock. I can open it up, and guess what? Now I don't have to worry about it anymore.
And you can also use geofencing because, you know, one of the things with MFA and you know, MF2, you know, it's basically it's you know, something you are, you know, and something you know. So basically if you have and something you have. So basically if I have a phone and I use biometrics with that phone, if I use geofencing when that phone is within range of that printer, then I can have access to it. But if I'm not, you know, first we're going to go to the MFA, and the MFA going to say, hey, are you allowed? Okay, where's your verification? Okay, I sent you a code, put the code back in so I can verify that you are. Hey, the geofencing said, hey, this device is trusted. And then it's close to the printer.
Yeah. Let you in. See, that makes sense too, because like for a lot of cases, that's the one problem is that you're not making many accounts when you spin up that first instance of mainsail fluid or anything like that. It's going to ask you for your account, but then it's not going to ask you to create extra accounts, and you're going to have to figure out how to use Linux to make those.
Right. And then the other thing, like Nick and I'm pretty sure John, is you have to be smart too. Like, I mean, you don't just you don't that your edge of your network. It's not to be left open. You can have a DMZ that's open, but the device that you're using to connect to the network should be only going out. You know, it should be.
We're blocked by a VPN.
Sending traffic out. You ain't bringing nothing in.
Unless it's blocked by a VPN.
Yeah. So I'm saying, like, there are things you can do to be smart. You know, take and physically tie your thing to that interest device that's your Wi-Fi or whatever, physically, configure your device so that it's secure and you're using the right type of standard, so that you're not using some old like WEP or something. Yeah. And somebody's like, hey, it takes like 2 seconds to crack this. So make sure your encryption is the right encryption. And be smart. Don't make your password default password.
Yeah, I gotta go change my
like password. He said,
password, yeah. Or user.
Yeah, I'm gonna have to go update my password.
Or even better, like I said, use geofencing and get rid of the fucking password. Yep. Get rid of the password. Sorry.
It's either that or, if you really want to get smart, freaking have it set up where there's all your stuff is on a handheld and you scan a barcode and it logs somebody in. Yeah. You have to be near the printer for that barcode to work. It'd be set like an internal plant network, for example. It's just there's different things that you can get. We start getting a more advanced category, dealing with that type of stuff.
Yeah.
So we want to cover the little bit of your resin printing, or
we could talk about it. To be honest with you, it's a different animal.
Yeah,
it's a whole different animal. So resin printing, or the printing that I'm doing, is DLP, digital laser processing. So the SLS is the standard way, and it's using a laser, and it's like etching it out and outlining with UV rays, a certain millimeter wavelength, so that it cures the resin. DLP is the whole screen is on the bottom, is 4K resolution, 6K, whatever your printer is, and it's doing the entire level at once, or that entire layer at once, and constantly peeling that layer off, up, and then going back down for the next layer, and over and over and over.
So when you say the 4K, what exactly resolution is? How do I, when I'm looking at that, what do I see when I see 4K compared to say, if I'm looking at just print PLA?
So it's very, very similar to how I would compare HD TV and how it used to be 720p and 1080p.
Okay.
So when you step up, it's got the resolution of the screen has more pixels. So it's using that. It's kind of piggybacking off of that ideal. So it's using those pixels to be able to create more detail. So pretty much when it's 4K resolution, it's the same as like someone would say that 4K TV.
Mm-hmm.
But this is like a 3x5 screen that's 4K, not your 65, 55-inch 4K TV in your living room. It's just maybe one panel of that. Mm-hmm. So all that is the resolution. And when I say 6K, 8K, it's just saying the resolution's higher. Resolution's higher. There's more pixels. So its ability to be more, precise and more, intricate in its design is there. However, it's still always going to be limited by the print model, the CAD model.
So does the speed of the hot end compared to the speed of the laser, are those factors in how compact the model would be, or it's just the nature of FDM?
Yeah, so yes, it is FDM is always going to be inherently, I don't want to say inefficient, because I think it's getting better and better. The more fine you can, especially with the variable nozzle, that's game breaking, because to me the gaps between some of your layers is a problem, and if everything has to be uniform, then some pieces are going to, that need more support are going to feel a bit more stress and strain, whereas if you can variably move that to make it a bigger nozzle and give it more, robust frame, then you're gonna pretty much fix that problem. So that's why I'm excited about the variable nozzle. But when you compare that to the resin printer, inherently it's smaller, because it's pretty much only moving in one direction. It only has one single actuator, linear actuator. It's only moving in the Z direction. It's not moving
it's
just straight down. Building. So it doesn't. There's no moving left, right. No 3-axis. Like the 3D is all. There's 2 frames or 2 axes technically being hit because of the frame of the LCD screen, and then therefore you only need to do the Z direction to create the depth that you're looking for. So when I get into that is, I don't want to categorize this as a beginner, because I don't think you should start out with this. People have started out with it, and I have some friends that have started out with it, and they're lucky that they had my phone number. Otherwise, they would have some problems. But at the same time, it's the reason I say that it's I don't want to say the most difficult, the most advanced to step into.
You're also playing volatile chemicals at that point.
Well, number one, that's the piece that why I think that puts it past is the volatile chemicals. You can have, resin like chemical burn. You can have, irritable breathing, lung damage if you're inhaling some of this. Like, it's not good for you to inhale that plastic, the fumes from the resin. Period. So shouldn't be operating it in a closed room, and you shouldn't be operating it in a room without ventilation, period. Number one, you're going to start getting headaches and things like that. And you should read your MSDS. Like, you should read that material safety data form or whatever came with it.
Proper
because,
PPE.
Yeah, to be honest with you, because I was getting headaches because I started out, I thought I had enough ventilation. I had an air purifier, I had my gloves, and I had not a great mask, but it wasn't a respirator.
Right.
But then I started noticing headaches, and I'm still smelling that resin. So then I got a better respirator that has like a HEPA filter in it, and less headaches when I'm working with those things. Because if you're working with longer prints, you're going to be in there for a while.
So it's probably ideal to have some type of exhaust system
100%
that can evacuate or have a enclosure that does those things with some type of HEPA filter, like you said. But what about supports? I mean, what's the difference in the supports, say, like when I'm printing something in PLA and the supports, or are we even talking any supports when we're talking resin?
Oh, so yes, absolutely you're talking supports. So there's plenty of points when, like, so I've watched the layers, like, I've watched what the LCD screen displays all the way through. So when you slice it, it runs through the layers, and it shows you its picture of each layer at each given point. And a couple of things that I'm looking for are artifacts or parts of the model that appear from nothing, that aren't attached to a main frame of the body, that are kind of like out in the open, just kind of sitting there, and whenever it would peel up, it technically would be too far from the print bed to peel because it's not attached to the print bed because it was off away from the body, and now there's nothing there to peel it up, so when it peels up, that's going to stay, and the next print that's going to go there, you're going to lose that entire arm. And everything from that layer up of the model is not going to print because it's going to be stuck to the bottom. So without supports, you wouldn't have the full print, and the reason is it's an endless tug of war. So the print bed is descending down, and the vat or where the LCD screen is at the bottom, and they kind of marry at the bottom. It layers the whatever layer it's on, hits it with the UV ray, and then a tug of war happens where the print bed peels it up. And if at any point in that print bed loses that tug of war, you've lost your print and it's a failure. And you're gonna have to fish out of the vat just old bits of pieces of resin.
But there's another process. Once you get a successful print, you have to go through like a pre-treating process.
Yes. So let's say we finished the print, right? It's not like an FDM printer. It's not, you can't peel it off and it's ready to play with. Like it's settled. No, with this, you should still use your gloves. Get it off your print bed. You should wash it with alcohol, preferably 99% proof isopropyl alcohol. You should let it dry, and then you should cure it with UV ray. So you don't have to do all these things with the like. So for me, I bought the Anycubic Photon Mono. And it didn't come with it. I bought the package deal with the wash and cure station. The station has a spinner. It rotates it around in a circle. I have a big tub that like it uses magnets to like spin the. I filled the tub with alcohol, by the way, and it uses it to spin that alcohol around my print, right? And then after that, I let it dry, and then I put on the same one, and I change the setting, and it just spins it slower and hits it with the UV rays at the right wavelength to finalize that final outer layer and also make it safe for human contact. Your skin contact. Yeah.
So I guess a resin printer maybe I can I print a part from a resin printer and put it on use it as a motor mount or
no.
Can I use it in a
Maybe for like an
I
RC
think
car.
it would be. So I think that it's also the same idea for like, FDM with TPU and PLA.
Yeah.
TPU is not the same as PLA.
Yeah.
But you use the same machine to print the like I print a tire on PLA. It's going to be rigid. It's not going to bounce. I can print it with TPU. It's going to be bouncy. It's going to be flexible. There is materials that are liquid that you can also do the same. Most of them are going to have like kind of a rigid like. It's like a crystalline structure more towards the resin when it's hitting that. But if you have a specific mixture, there are some like N90 or something like that. I can't remember the
Is that the nylon one or something like that?
But yeah, there's chemicals in it,
okay.
and the chemicals react in such a way that they act like a TPU as well.
And when I was saying motor mount, guys, I don't mean an actual car. I mean maybe like a model that you put together.
Wait, you mean you don't want to be driving out there with TPU motor mounts and just kind of see what happens?
I mean, it's possible, but we'll find out quickly, that there are mechanical engineers in this world for a reason.
TPU, like vibration reduction. There you go.
No. Designed for high heat applications.
It's definitely a world of its own. It's not without its caveats and its benefits, but at the end of the day, it's going to be twice, maybe 3 times the process. So you have a 10-hour print on an FDM printer, you snap it off, you let it dry probably or cool down, and you're done. You got a 10-hour print in resin, then you're probably going to have like 40 more minutes of post-processing, and then you're going to need to let it sit out and dry, and then maybe you'll get to it a couple hours later.
So what I would like to do is, because I know we're getting close to the end, but I just like to do just kind of like throw out a caveat and let you two guys kind of grab it. What I've noticed, and these guys have been doing 3D printing a lot longer than I have. Like I said, I'm still
Not by much.
playing around with the Pro 3.
Trial by fire.
Well, I'm determined.
Mind you, I got my
These
printer
guys,
the first day he got his.
These guys know the statement I made and what I'm trying to do, so I'm going to stick to that till I get it done or until I don't have a choice. But the question is when it comes to, say, FDM and when it comes to, say, resin, what I've seen some people make some spectacular, like, cosplay masks in resin. And I've seen some people do some spectacular things with PLA making statues. And for the most part, like PLA is what we're using for those type of things. So beyond that part of the craft, where do you see these two technologies going for a consumer? Say from the homebrew guy in the garage.
Well, the thing is when you start dealing with like FDM and you start printing like PETG and ABS, you can probably do it in PLA too. Is like you talked about in the garage. I like to spend a little bit of time down there. Is like your tool cabinets. You can print dividers. You can print socket holders because if you've worked on a motorcycle, you've worked on any vehicle in the world, you've always lose your 10 mil. So have a spot to hold a couple 10 mils just in case because you're always going to lose those.
11 mil if you're in Japan.
If you own a Harley, that's the only socket you ever own. Because for some certain reason, everything on a Harley Davidson is a 10 mil. It's just how it goes. But like stuff for like the inside like clamps, for example. It's like for me, it's like welding and stuff like that. These like ABS clamps that I can get my hands on. If I melt it, who cares? I can. It's non-conductive. I can hold on to it and run a bead on it. But it's non-conductive. I don't have to worry about that. But I can use it to, if I'm using the chop saw or something like that. If something happens to it, oh well. It cost maybe 75 cents. Yeah. Let me go print another one, real quick. Oh, I don't have a level or a measurement tape for this to do this. Okay, let me go print off something real quick. Yeah. It's the quick turnaround stuff for like stuff around the house, mounts for TVs and crap.
Yeah, 100%. I have a TV mounted with the printed ABS mount.
Yeah, it's like your curtain rods.
Yeah, I got my You're absolutely right. I got my curtains held up by 3D printed dragons.
And it's like everybody, I know John has printed these himself, is, you get some of those people out there who you get yelled at by your significant other about the couches like that going to scratch the floor. Okay, so get some TPU and print out little circle things and stick it up underneath the furniture, make it a slider.
Size it down a little bit, get a coaster.
Yeah, that too.
So there's so many things. So like if you're asking like where does the future look like it's headed, to be honest with you, I think that FDM is closer to what it's just easier for a wider audience. So if I'm thinking that that's going to be more of the more prevalent, like I make what I need now. As synthetic resins and things like that grow, I have no doubt that FDM will be taken over by a resin or some type of printing in that matter because of the amount of detail. It can be that much more exact. Right. You've got
like your tabletop guys.
Or,
and what is it? You and me were watching something the other day on
the
YouTube.
Adidas.
Yeah, well, the Adidas one where they're making shoes.
Yeah.
Out of the soles out of resin printers. But Jamie, when he printed the entire Mandalorian mask.
Oh yeah.
That's printed out of resin.
Yeah.
Big format resin printers. They are the way of the future. At this point.
There is another, but it's not a desktop yet. Powder base.
Yeah. Well,
I think powder base,
like metal, like powder fusion.
Well, just powder resin. We saw one today where they had a manufacturing facility, and that was one of the things they had where they were doing components for people, and they were basically getting them into a certain spec. So if you can get the right powder, but like I said, that's not desktop. That's industrial.
Yeah. I'm gonna say that's what we would get into if we were talking alternatives because there's the arc the arc wire.
Yeah, arc wire.
Something like that. Welding. So where they're making the spaceships and things like that.
Oh,
It can get robust. Yeah. It can really get like very robust in what you're making. So
you start going outside that spell, that realm.
But I think the thing that I'm probably more excited about is at least creating new makers.
Yeah.
It's forcing it too.
It's also improving the STEM community.
Yeah.
Little by little.
Because it pushes everybody a little bit.
And I think if we can improve the STEM community little by little, we'll make better engineers.
Yeah.
We'll make new engineers. People who are more interested in, going to sending a human to Mars and beyond, and deep space exploration and putting a printer back on, well, not just the International Space Station, but putting one on the moon, putting one on Mars. We need people that want to do that. We want people that are interested in that type of stuff. We need people that are going to take over, that generation and see it forth, from where it's at. Time to make Star Wars real. And not Star Wars, maybe Star Trek, make it real. It's about time. And I think we're getting to that point.
Yeah, we're getting close.
But it's like, if we can continue to improve the STEM community, then, we can make one new engineer now, and you'll make a new aerospace engineer, daily, for life at that point.
Then it's not like touted as this like stigma where it's like that's so difficult to do. It's not. Just have fun, and it like the progress will come.
And I think that brings us to the end. I know we ran a little long today, a little longer than usual. But the thing is I want to thank everybody. I've been looking at the numbers stuff like that throughout the last month. And we're getting a lot of hits from different areas still. Some from the same areas. We're pretty happy about that. We wouldn't be doing this if it wasn't for y'all. We wouldn't be, saying thank you if it wasn't for y'all. I know that, we definitely have some diehard listeners from different parts of the world. And, hopefully maybe one day we'll do a virtual meetup or something like that, or, get everybody on board, actually have a conversation, and then, or, at that matter, we can, we'll try to do an in-person meetup in, some different areas once we get some stuff moving. I think that's definitely, a long-term effect is, trying to, travel globally to some of these, different events and stuff like that and say hello to the guys, say hello to everybody, kind of stick our faces out there. But, that's here nor there. But I just want to say thank you. Y'all have a good night. I'm going to pass it over to the guys for the final words. All right, John.
I'll let John let you have the final word, but I'll just like to say we also appreciate all the support. We appreciate you guys tuning in. We're still trying to come up with some ideas for you guys so we can maybe if we can reach, say, 5,000, we would try to do some kind of giveaway. You know, maybe you guys give us some ideas of some of the things you think. You know, maybe we got a few ideas, but we'd also like if you guys would like some more content, or if you're interested in a live stream, we could do a live stream with you guys.
And go check out the YouTube channel too for that.
Yeah.
If we're gonna do a giveaway, I want at least a couple hundred subscribers on the YouTube channel too.
And then the other thing I like to say is like Nick was saying, as far as when we're talking about some of the kids that are coming up now, you know, maybe we get the kid that makes Skynet, you know, and maybe they make it right. But I'm turning it over to Judd. Thank you, guys.
Yeah, ChatGPT dangerous.
Most of the time it'll be like one of us who's just gonna put, you know, and they're making that just for
somebody
laughs.
hit play and they're like, "Oh no, make it stop, make it stop." Not good, not good.
Or the ones that figure out a way to make everybody else's life miserable because we think it's hilarious.
Oh yeah. But yeah, no, guy. I'm very appreciative. I'm very thankful for everyone listening. It's, you know, not every day do we have something that we can get this information out and kind of try to promote well-being or growth in that matter, in STEM and things like that. So thanks for listening. One of the things that I wanted to say also is that if you have an idea of maybe a print that we haven't like spoken about, and you're like, hey, you forgot my printer. My printer is the longer blah 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 this that. That's fine. We'll talk about it. We'll shoot. I might even want to get one and look at it, see how it works.
Send us the information on it. We'll take a look.
See, if you've got a printer you're passionate about, or if you have something that you think is a better printer, or you think that we're wrong about something, let us know.
Yeah, we still are going to do the vacuum chamber printer.
Yeah.
That is still going to happen.
And one other thing, we still want to have the print. We want to do the print of the month. Send us a picture of something you printed, or a video, so that we can take the best selection of those and spotlight them, and show people some of the things you created. So let's get the community.
Vulcan R Tech at, on Twitter, Vulcan R Technology Solutions on Instagram, along with the Tech at Lunch. Come out, find us,
anywhere,
get involved.
Send it to us. We'll see.
And if they don't want to do that, then we could even issue a challenge. Hey, this is what we're printing this month. Everybody printed. Let's see who printed it the best.
Yeah, we'll post something on YouTube. We'll do something on YouTube real quick and kind of see, hey, this is what we printed. This is a quick, hey, let's see how you did, and if you have any problems with it, let's take a look.
Yeah.
So, something quick. So, all right, guys. Y'all have a good one. All
Take
right.
it easy.
Bye. Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.